I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 3rd. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see a massive area of 20-foot seas extending from the Pacific Northwest the whole way to the dateline, with embedded seas to 31 foot, all aimed at the U.S. West Coast. Significant swell is on the way, as if there hasn't been enough already. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, a dip in the jet, sort of like right there. And what that helps to do is create a counterclockwise flow aloft and down at the surface, and that's the hallmark of low pressure. And if the low pressure is deep enough, it generates winds. If the winds are strong enough, they generate seas. If the seas are high enough, as they radiate away from the fetch area, they turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a little trough here in the northern Gulf, but what is more interesting is that the jet is completely consolidated, running from, that is, one singular flow for the most part, pushing from Japan the whole way over the dateline, north of Hawaii, and into the Pacific Northwest with winds to 180 knots in one pocket. And it's kind of unusual to get that for a couple of days or so, but it's been that way for now a couple of weeks. And the short answer of where we're going here is it isn't stopping anytime soon. This is normally what you'd see in like a big El Nino winter, but we're in the depth of La Nina and the same thing's happening. Cannot explain it, don't know what's going on, but you know what? I'll take it for all it's worth. All right, so let's put this into motion. So we move into Monday. You see much the same thing going on. A bit of an inferred trough here, trying to organize north of about 170 knot winds there, and that supports gale formation. You see it's starting to get a little bit dug out better on Tuesday, and then it fades. But then here comes another trough in the Gulf on Wednesday, digging out, being fed by 140 knot winds. As wind energy builds off Japan, we continue into Thursday. There you go, that trough even it actually kind of pinched, but still not bad. Another trough building behind that as we get into Friday. Wind energy building to 200 knots off Japan. This is just unprecedented. It really is. And it just continues as we get into Saturday. There we go. 200 knot winds pushing over the dateline. It looks like this is going to fall into a building trough. And there you go as we get into Sunday. And, it just kind of goes on from there. This is most impressive indeed. And look at this. It's actually running flat west-east down at about 38 north, pushing right into Cape Mendocino. Now, this probably would be problematic for weather into California, but, any bit of rain we could get, that would be a good thing. So you notice we've talked a lot of things. We haven't looked at anything but winds at 30,000 feet. We already can get a sense of the energy in the atmosphere. We get a sense of whether gales are going to form, and we could even get a sense of whether there's going to be weather and storms and rain pushing into areas near the jet. So a lot can be gleaned from just looking at the jet. All right, so let's go take a look now down lower in the atmosphere. Surface level wind, surface level pressure, okay? And this is where we get to see the effect of the jet on things that matter to surfers and people that do things in the ocean. You have to have wind blowing on the ocean's surface to generate waves. So that's why we look at this chart. All right, so right off the bat, you can see there's some sort of gale developing in the central Gulf here with 30 to 35 knot winds, a little patched, almost 45 knots up there, all aimed right at the U.S. West Coast. And then it looks like there's also some sort of secondary gale or another gale trying to develop out by the dateline. That's as of right now. Put this into motion as we get into Monday. You see first gale pushing inland, a much broader fetch developing with 35 to 40 knot winds from a point north of Hawaii to well west of the dateline, all aimed off to the east-southeast. Think those winds are going to get some traction on the ocean surface? They indeed will. And that continues as we go into Tuesday. The leading edge of that starts pushing into the Pacific Northwest on Tuesday. Another system starts building north of Hawaii with 50 to 55 knot winds on Tuesday night, sweeping off to the east, moderating some, still pretty broad in coverage. Another secondary gale builds from that on Thursday, and look at this, 1, 2, 3 gales in flight on Thursday, all of them building. Look at this, 45 knot winds off the California coast Thursday night into Friday. 55 to 60 knot winds pushing over the dateline, and another one with 45 knot winds pushing off Japan. This one, most interesting indeed. They're so close to each other. It's just, again, sorry, I'm a little bit incredulous, but this is just an unbelievable run of weather forecast here. As we get into Saturday morning, still 2 gales. 40 to 45 knot winds in the Gulf, another one of 45 knot winds over the dateline. Where are we at here? And they merge into one massive system pushing 35 to 40 knot winds again towards the U.S. West Coast. And here we are now, a week out, and still just massive amounts of fetch. Sure, maybe it's not huge in terms of high wind speeds, 30 to 35 knots, but it's covering 1,500 nautical miles effectively. There will be days upon days upon days of swell from this. Some of it aimed a little bit north, not great for Southern California, but not bad either. I mean, today we saw video of surf in the southern end of Southern California that was solid double overhead and glassy and bombing. Up in central Northern California, it was 12 to 14 foot Hawaiian and sheet glass buried in fog, but there was solid waves, and Hawaii's been getting their fair share from all this as well. So, a lot going on. Let's go take a look at the effect of these winds on the ocean surface. All right, so we're going back in time to Wednesday. What was that, 4 days ago? And, of course, there's this strong system that has produced swell that hit Northern California yesterday. It really slammed, that same swell slammed into exposed breaks in Southern California today. But it's the system back here behind it that we're looking at. And just keep your eyeballs on this. Because this thing really, you go, well, it's not any stronger than the other one. And from a sea perspective, you're right. 59-foot seas. But this one is apparently taking the record for the lowest central pressure of any storm, not a hurricane, but of a non-tropical storm in the North Pacific in recorded history, 921 millibars. That beats out 2 earlier systems in 2014 and then again in 2015. That was during a major El Nino. We're in a major La Nina, and still the same thing's happening. There is apparently much latent heat energy, either in the atmosphere or in the ocean, or both, feeding storms like this. All right, so anyway, this system pushed over the northern dateline. Swell from it has been generated. You see, it sort of hung around here and then continued with like 43-foot seas into Friday night and Saturday. And then here we are moving up on Sunday. Remnants of it are now in the Gulf. All right, the swell from this system poised to hit the U.S. West Coast starting tomorrow. And I think energy from this is already hitting Hawaii, though indirectly so with much smaller size. All right, looking forward. So here we are, 18Z Sunday, which is about 10 a.m. Pacific time. That system sort of fades out. Notice a little low develops here on Monday. Right off, you can't really tell that it's a low, but seas are pretty strong. They start pushing into California, northern and central California on Tuesday. But notice a new gale builds back here. Pretty broad area fetch. Because seas aren't that high. They're not 55 feet or whatever we're kind of getting used to, the new normal, the new ridiculous normal. But still, a broad area of 26-foot seas, like filling 1,000 nautical miles. That's good for good solid 15-second period swell with seas to 34 feet in two pockets. So with intermixed 17-second or 18-second period intervals, that pushes into and through the Gulf into Wednesday. A new system builds embedded in that with 49-foot seas on Wednesday morning, and then fading to 43-foot seas, another bout of long period swell. We're talking 20-second period swell probably from that, or we'll give it 19 seconds. And then a secondary system builds embedded in that. And here we go. 1, 2, 3 systems on Thursday evening. One right off the coast of California. Doesn't impact it directly. Here comes another one with 53-foot seas north of Hawaii on Friday morning. And that one fades a little bit. And another one back off the Kuril Islands, generating swell targeting Hawaii pretty well. Look at these two. Normally in a normal year, if you saw two lows with 41-foot seas back to back like this, you'd get all excited. We're yawning because that's like, oh, that's nothing compared to what we've been having. But still, the point being, broad area. Look at this. Supposedly on Sunday, a week from now, the entire Northeast Pacific to the dateline, full of 20-foot seas minimum, which will get you 13-second period swell, and up to 37-foot seas, which will get you in the 18-something period, 18-second period. So, again, massive amounts of energy on the way, and there we are a week out, no end in sight. Now, the million-dollar question is, okay, great, piles of swell, but what's the weather going to be? Southern California, not so much of an issue. Hawaii, not so much of an issue. But once you start creeping north of Point Conception, you'll see it's just front after front after front. And the fronts bring south winds, and that tends to shut down a lot of breaks, especially ones with south exposure. So we'll just put this into motion. We're looking at Hawaii. We're just going to assume for the most part this high pressure here has been sort of very prevalent, and that's just making for more or less trades into the Hawaiian Islands nonstop. All the focus, Pacific Northwest, the northern part of California. The dividing line seems to be the Golden Gate or somewhere roughly in that area. All right, so we're on Sunday night. Let's go right to Monday. Here we go. South winds. And this is a low-res model, so that's the other thing we need to talk about for 2 seconds. And a lot of the sites that you see that do wind forecasts and spot-specific forecasts for, I just want to look at my break. They use this, and this, from a wind perspective, isn't always right. It gives you broad brush strokes. It's good for swell and that sort of thing. But tracking your local wind, we have some high-res wind models. We're not going to get into digging through all that. But the high-res wind models will tease out much better what's going to go on at your specific break. The downside is they only go out 84 hours, or in the case of Hawaii, only 60 hours. But when in doubt, use the high-res models. That will save you some heartache if you're expecting there to be perfect winds, and that's what happened a lot in Northern California yesterday. The forecast said calm winds. It was all driven by these low-res models, and the reality was, if you looked at the high-res models, they said south winds all day, and that's pretty much exactly what happened. All right, so here we are, Monday. South winds, that's an obvious, that's going to happen, and Hawaii still into trades. We get into Tuesday, now a little bit of high pressure here, another front queuing up off the coast, but maybe there's a window there, at least in central California. You get further south, things are much less of an issue. Wednesday, kind of the jury's out. Could be south winds, probably. Dividing line, maybe Monterey Bay. As another little low whips up, another broad low. Trade still for Hawaii. We're into Thursday. Maybe a window again, but again, a broad system building off the coast. As we get into Friday, full-on south wind event. Trades fading for the Hawaiian Islands as we get into Friday. And then Saturday, where are we? Here's Saturday. Maybe another window of opportunity for California. What is this? Hawaii kind of a mixed wind pattern. Need to go look at the high-res model to figure that one out, but we're way too far out for that. And then Sunday, we're seeing again high pressure trying to hold on. Unknown how that'll play out. Trades for the Hawaiian Islands, just thousands of miles of fetch aimed at the coast. So, and then we get into Sunday night into Monday. Hard to say how this is all going to play out, but it sort of looks like the line, high pressure, maybe it's going to creep a little bit north and there'll be better wind patterns for, we'll call it northern central California or southern northern California. Precip for California. This is what we're going to focus on. Give us some rain. I mean, don't really want it because it kind of, when you have precip, you have south winds. And that really tears the surf apart. But we need a snowpack in the Sierra. There is snow. We'll get into that in a second. But, you'd think there'd be a lot more than there really is. All right, so here we are, Monday morning, rain. There's that dividing line, it almost looks like. Making it down into central California. Snow developing for the Sierra. Maybe a pretty good batch as we get into maybe Monday afternoon. That fades out real quick. We're just looking at California here. Another batch of rain setting up Wednesday, pushing down right about somewhere between San Francisco and Santa Cruz, and it fades out there. No snow even for the mountains. Then another batch comes in on Friday. It makes it down to almost Point Conception. A little bit of snow for the mountains, but again, quickly out of there. No long and prolonged systems. And where are we now? We're into Saturday night and pushing into Sunday. Looks like maybe, again, San Francisco, the dividing line, more than likely. Let's go look at snowfall accumulations. Squaw Valley, what's that about? Maybe 28 inches, something like that. And most of it on Monday and then January 8th time frame, and then things pretty much stabilize out. Snow levels, not bad. This is the base of Squaw here. This is the top of Squaw. And so, the base could gets above freezing, at periods, but then at other periods, not so bad. Could be a lower. There's actually a pretty warm regime for Squaw, but Squaw is pretty low. Let's go take a look at Kirkwood. You can really see the dividing line here. Look at how much less snow is expected for Kirkwood, and Kirkwood's all of what? Maybe 60 miles further south, if even that. We're talking maybe 19 inches, something like that. And what was Squaw? 28 inches, something like that. The good news is snow levels, they're pretty low, not super low, but not horrible. And let's go take a look at Mammoth. Now, Mammoth, quite a bit further south, eking out, 3 inches maybe? They're higher. Snow levels are better, but this is the real issue here is we need snow in the Sierra to help our water level, or our summer water supply, and we're not seeing a whole lot. Yes, they have snow, and they're managed to get most of the resorts are able to get a good amount of terrain open, but we're way behind normal. I don't know the exact details. We could look into that, but again, it looks like a train of storms coming, but they all get chopped off at San Francisco. Most of them don't make it any further south. Their precipitation doesn't barely make it into Tahoe, and if it does, it's more northern Tahoe than southern Tahoe. So the northern Sierra get plenty of water. Southern Sierra that feeds like LA in that area, maybe not so much. So La Nina signature is pretty firmly evident in the rainfall pattern. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and the El Nino Southern Oscillation? All right, so first off, we like to examine what's going on with this thing called the Madden-Julian Oscillation. It's this periodic weather oscillation that travels from west to east on the equator. So this is the equator here. This is the Pacific. East Pacific here, West Pacific here. But it goes the whole way around the planet. And it goes from this direction to this direction. And when there's two phases for the MJO, the active phase and the inactive phase. The active phase is the one that we're really interested in. When it moves across the Pacific only on the equator. What it does is it's like a big low pressure system, and what it can stomp on the trades. It imparts energy to the jet stream, gooses up the jet stream, and then helps support storm formation. So, looking at the jet stream, you'd go, my gosh, we must be in some massive active phase of the MJO, but that is not the case at all. In fact, we're in the polar opposite. We are in a massive inactive phase of the MJO. You notice that by, look at the trade winds here. So this is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. Winds are from the east, over the East Pacific, Central Pacific, and strong in the West Pacific, what we call the Kelvin wave generation area. But it's not the actual winds, it's the anomalies, differences from normal for this time of year. Yeah, we have strong east winds over the East Pacific, but see these arrows, they're like going north or south. What we're interested in is the east-west component of the wind. We see nothing there, so these are normal. Same thing over the Central Pacific, normal. But look at this, when you get to the West Pacific, the Kelvin wave generation area, these east winds are much stronger than normal, okay? This is very indicative of the inactive phase of the MJO, okay? So why is the typically when you see this, the jet stream pulls apart, the storm track shuts down, and you don't get anything. And that was our fear for this entire winter, is that we'd be in this massive inactive phase of the MJO driven by La Nina. But, and I can't explain it, for whatever reason, even though you have these strong east anomalies, the jet stream is roaring. There is another source of energy somewhere, and it isn't in the Pacific, that's causing it to rage. I mean, it's to our benefit, but it is a bit of a head scratcher. Then next up, here's the forecast for the next week. So what are we looking at? This is the whole planet on one chart. The date line, 180 west, goes right through the middle of the chart. And this is time, so we can go back to December 4th, 9th, 14th, and then the 1 week forecast. All right, so this is just the east-west component of the wind. What we want is westerly anomalies in the Kelvin wave generation area, the West Pacific. West Pacific starts right about here, 135 east, goes to about 170 west. Okay? Reds and yellows are westerly anomalies. So we have strong westerly anomalies in the Indian Ocean, but we have strong easterly anomalies over the Kelvin wave generation area. All right, and they have been that way for months in reality, but they got very strong starting Christmas and are continuing now, and are forecast to continue for the next week. What we suspect might be going on is, yes, this is happening, but over here you have pretty strong westerly anomalies too, and I think that's what's feeding the jet stream over the Indian Ocean. And you notice the jet stream makes it to about California, and then it dies, and it doesn't punch inland. We suspect that because we're doing well in the Pacific Ocean because of the low pressure bias, the westerly anomalies that are strong and well developed and set up over the Indian Ocean, and so momentum is just carrying the jet stream past that over the Pacific to about the U.S. West Coast, and at that point it just falls apart. The other thing, also notice, westerly anomalies developing here just south of California. Not that that means anything from an El Nino perspective, but maybe that's helping give us whatever rainfall we're getting that's being fed by the jet, and actually probably the precip is coming the whole way from off the Indian Ocean. That's giving it just enough of a push that even though it maybe gets semi-shredded coming over the Kelvin wave generation area, it carries it into California. We get some, and certainly most of this energy, though, is driven up into the Pacific Northwest. All right, continuing on, looking for the active phase of the MJO, or the inactive phase. This is outgoing long-wave radiation forecast. Fancy words for cloud cover, okay? The blues are where there's more cloudiness, and you notice it's over Bali. Oh, there's 4 panels here. Day 0, Day 5, Day 10, Day 15. There's Australia, there's New Guinea. Dateline runs right there. The equator runs across there. There's South America, Central America. You get it. Indian Ocean here. All right, so active phase of the MJO right here over the Indian Ocean. Inactive phase of the MJO over the dateline. That, per the statistic model, is supposed to continue, maybe shifting slightly to the east over the next 2 weeks. So not a big change. That per the statistic model. The dynamic model, let's see what it's saying. It's painting a slightly different picture with the inactive phase of the MJO building over the next 2 weeks, but at the same time, the active phase also building. What does all this mean? Well, none of it looks like what we typically would look for. We want to see the active phase of the MJO, which right now is over the Indian Ocean. We want to see it right here, okay, in the Kelvin wave generation area. But that's not happening. And it hasn't happened all year. And it probably, I mean, at least this fall, and it probably isn't going to happen at all this winter, or even if it does, it'll be very weak. Okay, but we think we're getting benefit of the active phase being here, imparting energy to the jet stream, and then the jet stream just comes barreling off of Siberia, and its momentum carries it to about here before it starts falling apart. So that's our theory for the moment. Phase diagrams, another way to examine the MJO. So what are we looking at? So this is the statistic model. This is the dynamic model here. The MJO, active and inactive phase, typically move from west to east, from the Indian Ocean, over the maritime continent, over the West Pacific, East Pacific, under the United States, over the Atlantic, across North Africa, back to the Indian Ocean. The weird thing, this is the statistic model, this is the dynamic model. So where the heavy dot is, which is like right there, is where the active phase is. So you see that circle? Assume you're looking down on the, there we go, down on the North Pole, okay? And the MJO revolves around the equator. Wherever the active phase is, like if it's here, the inactive phase is on the other side of the planet. All right, so right now the active phase is inside the circle. That means it's extremely weak. Typically, you want your active phase way out here. So almost no MJO, and these are the different forecast tracks from it. It's supposed to essentially stay very weak and not move a whole lot the next 2 weeks, according to the statistic model. Dynamic model says, maybe building a little bit in the Indian Ocean, then crashing back somewhere over the West Maritime Continent. No real change. So whatever pattern we're in, it seems to not be governed by the MJO proper. Something stronger and larger is driving the path. So let's go take a look at the CFS model. This goes out 1 month. All right, same deal. Whole plan on one chart. The date line runs right up the middle of the chart. Okay, Kelvin wave generation area, i.e. the West Pacific, starts right about here and goes to right about here. You can see this dynamic pretty well defined. The blues and the dark blues are easterly anomalies, inactive phase of the MJO. The reds are westerly anomalies, active phase of the MJO. You see they're locked in. The MJO isn't even, we'll get into this in a second, but this pattern is like set up with westerly anomalies. They've been over the West Pacific. Well, you can even see it back in October. It started here. We had a little break. That's the dotted black contour is the inactive phase of the MJO, and it pushed easterly anomalies through the Indian Ocean. But then, ever since then, just solid westerly anomalies with solid easterly anomalies, very strong as of recently, over the dateline Kelvin wave generation area. The MJO, here is the inactive phased forecast. It doesn't even have any bearing, and you see as we get into late January, the solid contour is the active phase. We suspect that is going to have no bearing. So the MJO is kind of out of the picture right now. What's driving the global weather pattern is La Nina. And you can see that pretty clear here, this purple line. In fact, we'll go up here. So purple, they call it low. It's the low pass filter. MJO is the black line, okay? And there's two phases. It's either the dotted contour or the solid contour. Notice the solid contour here. that is a low pressure bias, which is driving westerly winds. So this is like a huge active phase of the MJO, completely locked solid over the Indian Ocean. And given it how permanent it is, what do you think that's going to do for the Indian Ocean once we get into summertime? Storm production will probably be through the roof in the Indian Ocean. Likewise, the dotted purple contour, a high pressure bias, is supposedly controlling the Pacific, but we have storm after storm. We think there really is high pressure because Hawaii is like high and dry, right? So I think there is a high pressure bias fully in the Pacific Ocean, but what's driving the storm track is the jet stream, and the jet stream is getting all its energy from the Indian Ocean, pushing it across the Pacific, and momentum is just carrying it, and we're reaping the benefit of that ultra strong westerly wind pattern signature in the Indian Ocean. Now we'll take it one step further. This is a 3-month CFS model. Same deal, whole planet one chart. Date line runs right up the middle. Kelvin wave generation area, West Pacific, starts right here, goes to about right here. Past performance is on the bottom. We have no contours on here, but you can clearly see blues, that's easterly anomalies, that's your La Nina signatures. Here's your yellow, your westerly anomalies here in the Indian Ocean. You see them getting a bit more pronounced. You see the easterly anomalies getting a bit more pronounced as we get into, mid-February, something like that. Let's overlay the MJO, see if we're even close. Okay, so the MJO, weak, single contour active phase supposedly occurring or just fading out now. Doesn't even mean anything. Another one supposedly in the Indian Ocean. It makes it to the far West Pacific and fades out. And then it probably actually continues over here. And you see, actually some westerly anomalies forecast in the Kelvin wave generation area in the February time frame. Normally we would say, okay, this is a big target. This is when there's going to be surf. But given what's going on now and that the MJO is almost non-existent, I don't know that these charts mean anything anymore. The one part that does mean something is, again, the low pass filter. The dotted contour is the high pressure bias. It's strong. If anything, 1, 2, we're in 3 contours in the Kelvin wave generation area today, supposed to go to 4 and hold into about mid-March. The low pass filter, the low pressure bias in the Indian Ocean, only supposed to build. The thoughts are, if this actually happens, and this is the mechanism that's driving the jet stream is supposed to be solid into the end of February at least, if not beyond. Our storm pattern, theoretically, could continue. So who knows? I mean, we're sort of in uncharted territory, so we'll have to see. Otherwise, the MJO proper, we're kind of starting to ignore it. And I don't say that lightly, because we have spent years researching the MJO, touting its benefits, but we're kind of in a spot now where when we say the MJO doesn't matter, I mean, it really doesn't. But that happens also during El Nino. When you have a strong El Nino, the MJO kind of loses meaning and the strength of El Nino just takes over in the Pacific. Again, we think the strength of La Nina is strong enough that it's sort of making the MJO irrelevant at the moment. All right, so with that said, let's go talk La Nina, El Nino. All right, subsurface temperatures in the ocean. This is the first component we want to look at. This is the West Pacific here, East Pacific here. This is data from the TAO buoy array. These are the anchor lines on those buoys, and the X's are sensors on the anchor lines. They report subsurface temperature data, and they relay it up to a central processing station. You apply a model, you fill in the gaps, you can see what the water temperature is doing. So you just eyeballing this, warmer temperatures in the West Pacific. The 29 degree isotherm, it's about where it's been, about 160 east. The 24 degree isotherm, about 170 west. It might have been over to maybe, or 170 east, I'm sorry. It might have been 2 or 3 degrees over here, but it's sort of backtracking some. The 24 degree isotherm, it actually backtracked a couple days ago, but now it's back to about 125. But you can just eyeball in this, you see warm water in the west, not so much warm water in the east. typical of La Nina. When La Nina is going, it increases the trades. We know that trades are blowing pretty hard here, and even stronger over here. Takes all the warm water that could be here, pushes it off to the west, and it starts building here in the far west Pacific. And we're going to see a little bit more about that in a minute. All right, but it's not the actual temperatures, it's the anomalies. Differences from normal for this time of year. You can clearly see the pattern. 1, 2, 3 degrees centigrade above normal. That's what, about 5 degrees. And only making it to 160 west, not even making it to Hawaii. In the east, below normal temperatures, 1, -2 degrees. So what's that, about 3 degrees below normal. But the interesting part here is these temperatures are nowhere near as cold as they were a month ago or 2 months ago. They're still cold. Not where they should be, but we're getting the sense that maybe as much cooling as there can be in this area has already happened, and if anything, it's sort of giving up some of its energy. Let's go look at one other chart. Right here, same data, but you clearly see this much warmer regime in the far west Pacific. Colder, but not nearly as cold as it was. 1, 2, 3, 4, 5... 1, 2, 3, 4, 5, like 3 to 4 degrees below normal in pockets here. But weeks ago, it was far colder, and we'll get into that in a minute. All right, but again, so, one other thing. During a normal year, or even during a El Nino year, when the active phase of the MJO would move over the West Pacific, it would reverse the trades. Right now, the trades are blowing from the east, so from here to here, the whole way across the equator. But if you got wind starting to blow from the west here, it would take this warm water, break it off, and start pushing it towards the east. And you get a ball of warm water. And if you got successive balls, or what they call Kelvin waves, warm water would start building in the East Pacific, and that's how you kick off El Nino. One more chart here. This is from we'll go up December 29th. You see that there. This is, they call it ocean height anomaly. Okay. What that is, just another way to confirm temperature data. Okay. -10 centimeters, -15 centimeters. This is the equator right here. South, Peru right there. Ecuador there. Central America. Okay, the equator there, New Guinea there, the date line there. All right, what you see is negative anomalies, like an anvil going like this towards the west. You see positive anomalies, +15, +20 in pockets in the far west Pacific. Okay, cold water at depth contracts. That creates a little dip in the ocean surface, and that's what the Jason 3 satellite is picking up here. A depression. Strip out the Jason 3 satellite rotates around the planet, measures the height of the ocean. But if you take out the waves, the wind waves, the tide, you can actually see the difference in the spherical surface of the planet over the oceans. And what we see is a depression here. All that means is cold water is in place off of Central America and going the whole way to the dateline. What we also see, though, is the ocean is rising. Warm water expands, not a lot, just a little bit, but it creates a bump, and you can see that in the West Pacific. So, the point being, this is classic La Nina kind of signature, but as warm water continually gets driven over here and builds up and up and up, at some point the dam's going to break, and all this warm water, as soon as the trades even give up a little bit, it's going to start sloshing to the east, and that is typically what happens to kick off El Nino. So here's sort of a historic look of what's been going on. This is the East Pacific here, West Pacific here. The yellows, oranges are warmer than normal temperatures, blues colder than normal. In April of this year, you see this was the last Kelvin wave. We talked about the active phase of the MJO driving westerly winds, taking warm water, pushing it from the West Pacific to the East Pacific. It stopped. Trade started building strong. We got this big cool pool that developed in the East Pacific, reached almost to the date line. We got something that almost tried to be a Kelvin wave back in July, but it faded out quickly. east anomalies took control. This was the peak of the event as best as we could tell right here, right around October, Halloween time. And now notice we're getting some slackening of the cool water at the moment. And notice we went from, in February, cool water in the West Pacific to a markedly warmer pattern building in the West Pacific now. The question is, at what point is it all going to slosh back? We don't think it's going to happen this winter. There's just too much going on in the atmosphere. Things don't turn on a dime. The atmosphere is a big boat. It takes months to change. We're thinking maybe next winter is when the dam will break. All right, we're going to try to pick up the pace here a little bit. All right, sea surface temperature anomalies. Okay, Chile and Peru there, Central America there, Mexico, Hawaii right out here. The equator roughly right along here. The blues, colder than normal water temperatures. We know we have subsurface cold water temperatures, but it's also manifest on the surface, driven by easterly anomalies causing massive upwelling. You see, this is the classic La Nina signature going the whole way out to the dateline. Point to notice, these temperatures are not as cold as they were a month ago over a broad area. And there was embedded, see that like that deep purple there? That was embedded all along here. All that's gone. There's a little bit of cooler temperatures here. They're all getting pushed off to the east and fading out. The 1 week trend, a encouraging trend here. Water temperatures, the reds mean warming off of Peru, off of Chile. Distinct warming along the equator right here. Here's the last little bit of cooling pockets. And all we really care about is generally right in this area. It's what happens on the equator that matters. You go, what about all this here? Well, those are more just byproducts. What drives the weather engine is the weather on the equator. And you can see much warming occurring off of Ecuador. Just another look here, the backed off picture. You see a lighter blue regime down here that was much colder a month ago. A little bit of cooling right along there, but even the previous chart doesn't show that. It suggests that all this is past its prime. We think we're past the peak of La Nina. Water temperatures in the Nino 1.2 region, that's the area right along Ecuador, Peru, the Galapagos Islands, kind of a noisy area. Temperatures today, minus 1.305 degrees below normal. La Nina, this is not the official monitoring region, but half a degree below normal for 5 consecutive months is considered La Nina. We're way below that. Trend, we thought we were rising. It kind of fell a little bit in the past 2 weeks, but now is working its way up. But it's the official El Nino monitoring region right here, the Nino 3.4 region. Temperatures minus 0.975 right there today. Actually rising, not much, but a little bit. We were down at minus 1.6, 1.65 degrees there in the Halloween time frame, and now to be above a degree below normal, that's a marginal improvement. And then finally, the atmosphere. So we talked subsurface temperatures, we talked ocean surface temperatures, now we're looking at the atmosphere above. What does the atmosphere, is it sensing the changes in temperature in the ocean? Okay, the way they do that, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti's in the Pacific, Darwin's almost in the Indian Ocean. All right, when the index is negative, you see it is not negative, that suggests lower pressure over the Pacific. When it's positive, high pressure over the Pacific. All right, so the index today, 23.42. This is the daily numbers. We're just looking at that. You can see positive, rock solid positive for, we'll just go down here the whole way to the end of the month. Rock solid positive. No indication of El Nino at all. Clear indication of La Nina. 30-day average basically takes the noise out of this. We're way up at 17.41. That's a clear La Nina signal. And it has been, let's see, we'll go back a month. It was down to plus 9.19. Now it's up to 17. Okay, and then the 90-day average, that's 3 months. It takes 3 months of data to get this thing going. We're at 10.26. I've typically said when we're about 12, that is La Nina, but it's a lagging indicator. We already know we're in La Nina. I don't need this index to tell us that, but what the daily index is telling us is that we're not crashing. We're still quite positive. And as far as the atmosphere is concerned, again, we talked about it. It's a big boat. It takes a long time to move. The atmosphere clearly and undeniably understands that we're in a La Nina pattern. Here's the 30-day moving SOI average. You can just, or the SOI index. Today, we're almost pushing off the chart positive. Anything above about a 5, well, we could say a 10 is clear La Nina sign. These downward pushes are the active phase of the MJO. These are the inactive phase of the MJO. You can see the trends since you could see a year ago, October 2019, we've just been on a steady rise. The inactive phases of the MJO stronger than the active phase is driving us positive. No surprise here. La Nina in control. So what's the plan for the next 6 months or year or whatever? We look at the CFS version 2 model for sea surface temperatures in the Nino 3.4 region, the official El Nino monitoring region, basically on the equator from a point south of California out to the dateline. All right, so temperatures have been on a steady downward plunge. They made it to about 1.25 degrees below normal in October. We know that. They've started to perk up a little bit. 1 degree today. That's, right about there. This is the middle of the month. So by mid-January, they should still be there. But notice, upward trend forecast to about almost moving out of La Nina territory in April. Now this is a new twist. The model suggests heading back down into August or so, back into minimal La Nina territory. For weeks the model's been saying temperatures in about the minus 1/4 degree range, which would basically be neutral. But now heading downward as we start moving into fall of this year. Would this be a 2-year La Nina? It could be, and it could do that, and it could make it till typically the turning point. When you have big dramatic turning points, it'll happen as early as February. Maybe February of 2022 would be where we get a shift to El Nino in a dramatic fashion. Hard to say. I mean, just looking at the water temperatures and everything right now, it seems like La Nina's fading. This model is not always right, and it's always a bit of a drama queen, so we'll have to keep our eye on it. The good news is, all that doesn't matter. The jet stream is roaring. The storm track is on fire. We think the Indian Ocean is feeding all that. La Nina is actually doing it. We're in La Nina in the Pacific, but there's a pile of latent heat energy in the Indian Ocean. It's pushing up into the upper levels of the atmosphere, feeding the jet, and we are reaping the benefits of that, not so much in terms of precipitation, but certainly in terms of storm production. And it's a very east-west directed, or west to east directed track. Hawaii getting a lot of sideband energy and solid. I mean, for this week, they're going to see consistent 10-foot surf for days, but the U.S. West Coast could see consistent 15 to 20-foot surf. The issue is, of course, weather, front after front after front. And the interesting part is they're not that wet unless you're north of the San Francisco Bay Area. So, regardless, we had forecast this year would be pretty much a bust surf-wise. We were wrong in that, and we will admit it with a smile on our face because we're getting the benefit of it. I'd rather be expecting doom and gloom and be pleasantly surprised than the other way around. We don't like to hype things up. All right, so the good news is piles of surf on the way. I mean, you can't even get into the details and track all the individual storms hardly because they're just coming. And the models, they have a difficulty more than 3 or 4 days out. So you got to kind of stay tuned. The weather, all the info that we were looking at here today is all available on stormsurf.com. So you can go there, you can follow the models, and then use that to sort of test your knowledge, wrap it up, and then watch the video next week and see if your personal forecast is on track or not. But either way, looks like we're in pretty good shape. And beyond that, more to come. For now, the pattern is working to our advantage. Let's make the most of it. If you enjoyed the video, give us a thumbs up. Where are we at? Oh, there we go. Give us a thumbs up. We'd appreciate it. If you have comments, please comment. We're trying to get as much surf as we can. We haven't been quite as good at responding to comments as we should be, but we're going to try to. But again, we've said when there's surf during a La Nina year, you better go get it. We're following our own advice and trying to do that. All right, if you haven't subscribed, please subscribe. You'll get a notification when we post the videos. If you don't want to subscribe, that's okay too. Just go to stormsurf.com. At the top of every page, there's a little banner with a link to the video. All right, so that's it for this week. If you're going surfing and the waves are big, use your head. Be smart. We don't want anyone to get hurt or worse. So use the appropriate amount of caution because there's a lot of energy in the ocean right now. All right, other than that, stay safe, be happy, go get some waves. We'll do it again next week. Same time, same channel. Thanks for watching.